Hello everyone, my name is Shahin Alam. I am currently doing my PhD in agriculture and biological engineering at Penn State University. A significant part of my research involved the evolution of PFOS and other emerging contaminant occurrence and fate in rural water supply and beneficial water use system. Today I am going to present my research entitled Assessing the Potential Impact of Biosolid Application on the Presence of PFOS compound in nearby groundwater wells. It is a citizen science-based study in Pennsylvania. Let's introduce emerging contaminant. Emerging contaminant are synthetic or naturally occurring chemical or any microorganism that are not commonly monitored in the environment but have the potential to enter into the environment and cause a known or suspected adverse ecological and human health effect. The main sources of emerging contaminant comes from industrial agricultural activities, wastewater treatment, personal care product uses, photodegradation, bioaccumulation, microbial degradation, land filling, and obviously this emerging contaminant not just available in water and soil, but also it is viable in air. And this emerging contaminant have environmental and human health impact. So that's what we are going to discuss today. PFOS is an emerging contaminant. PFOS stand for per and polyfluoroalkyl substances. PFOS are found in a wide array of consumer and industrial product. PFOS manufacturing and processing facilities using PFOS in production of other product. Airport and military installation are some of the potential contributor of PFOS release into the air, soil, and water. PFOS introduced in 1940s based on the chain length, carbon chain length. PFOS classified into two categories. One is a short chain, which chain length is less than 6 carbon, and one is another is long chain, which chain length is greater than or equal to 6 carbon uh, chain. And the chemical properties of PFOS is basically repel oil and water, flame resistant and resistant to degradation, and that's why it is called as forever chemical. Let's introduce my project. In the Commonwealth of Pennsylvania, there are no regulation for installation of portable wells, which has resulted in public wells ranging from shallow hand dug wells to deep wells protected at the surface of watertight casing. Across the state, more than 1 million private wells supply potable water to farm and rural houses, making rural residents more likely to have access to drinking water that does not satisfy primary drinking water standard. While many public drinking water supplies have been monitoring PFOS presence in anticipation of new drinking water standard, people on private wells face challenges in ensuring that their potable water content level of PFOS compound deemed safe. Given that water quality analysis for this compound is expensive, so this project, we try to analyze the impact of biosolid application on the presence of PFOS compound in nearby groundwater wells. Thousands of PFOS chemicals are present in the environment, but we are particularly interested in this 20 PFOS chemical, with carbon chain length in between 4 and 14, and whether they are commonly used as a PFOS precursor or they are used as our daily activities. Due to their widespread use and persistent in the environment, most people in the United States have been exposed to PFOS. There is evidence that continued exposure may have a specific level of certain PFOS may lead to adverse health effect. Health adverse health effect including reproductive effect of pregnant women, increased risk of some cancer, cardiovascular diseases, reduce ability to body immune systems to fight infection, including reduce the vaccine responses, interference with the body natural hormones, increase cholesterol level, and risks of obesity. And certain adult and children may have higher exposure of PFOS. Considering these substances detrimental health impact, US EPA and several states already take initiative for the proposed drinking water standard. US EPA already set a standard for PFOS and PFOL level less than 70 ppt. Pennsylvania already proposed a standard for PFOA less than 14 nanogram per liter and PFOS less than 18 nanogram per liter. New Jersey, New Hampshire, Vermont, New York, Michigan already proposed or set some standard for their drinking water. Here is the list here. Project goal and objective. The overarching goal is to address the key data gap of our understanding the occurrence and fate of PFOS in rural landscape and agricultural operation and their impact on rural water supply. Our research is in combination of field laboratory and modeling activities to reach our objective. Objective number one is basically determine the impact of beneficial biosolid landfill disposal in agricultural system on the occurrence of PFOS compound in rural private freshwater resources. Objective number two, compare the PFOS concentration of Pennsylvania Department of Environmental Protection's public well water data with our private well water data across the state. MWON is a stand for Master Well Owner Network, which was established by Penn State Extension. It is made up of 800 trained volunteers who offer rural homeowners the information they need to safeguard and manage their drinking water supply. In this slide, I try to visualize the Master Well Owner Network's location in across the state of Pennsylvania in combination with the biosolid application site across the state of Pennsylvania. Recruiting volunteer, we actually prioritize counties across the state of Pennsylvania. The county's name is Cumberland, York, Lancaster, Indiana, Westmoreland, Washington, and Butler. The middle column is the active biosolid application sites number in these counties, and the right column is the master well owner network homeowner number in these counties, and we send them an email whether they want to participate in this study or not. Based on their responses, we recruited 68 volunteers by the help of master well owner network. Recruiting volunteer, we also send them a basic survey sheet that include their name and addresses, what types of drinking water supply they are using, like private wells or private spring or public water supply. Actually, our study is confined with only private wells and private spring, and we also told them whether they are able to participate our study across our journey. So based on their responses, we recruited volunteer. To maintain the standard process and procedure for sample collection, we send sampling kits and instruction to the study participant. Among the sampling kits we send to the participant uh, are a sample collection procedure, sample submission form, one black Sharpie marker, two pair of latex gloves, two reusable ice pack, one colorless plastic bottles filled with nano pure water in a bubble wrap bag, two empty plastic bottles wrapped in bubble wrap bags. Among these two empty plastic bottles, one plastic bottle's label well or spring water sample, one plastic bottle's label fill blank sample, foam cooler, cardboard shipping, and prepaid UPS shipping label for overnight shipping, so that we can get their sample in a quick way. Let's discuss the result. In this table, the maximum value of our PFOS compound is on the right column and in nanogram per liter. And for your information, N.D. is not detected. and N greater than not detected stand for the number of whales that are above not detected. That means their value is their PFOS value is detected in our analysis, and we got that PFOA and PFOS, the maximum value is 16.0 for PFOA, and maximum value for PFOS is 16.49. And we our detected number of sample which has PFOS 44 out of 68 sample, and PFOS is 40 out of 68 sample. They're basically used for make PTFE and other non-stick coating, and PFOS uses firefighting foam, surfactant, fabric, and food packaging, and PFACXS highest value we got like 4.0, and the number of detected wells is 26. PFBS highest number is 12.0, and number of detected wells 31 out of 68. PEA, uh, the maximum value of PFOS is 12.0, and the number of uh, wells is 28 out of 68. And PFH6A, number of detected wells is 32, and maximum value 13.0. PFHPA, number of detected wells is 20 out of 68, and maximum value is 5.8. They are almost all uses for our daily activities. In this slide, I try to visualize the total PFOS data. Here, N.D. stand for not detected, as I told before, and red dot stand for active biosolid location. For your information, the distance between active biosolid location and our intended sampling site location in between 0 to 25 miles. This slide, I try to visualize PFOS plus PFOA data of our analysis, and we found that no sample exceed EPA advisory level of these two chemicals combination 70 nanogram per liter. However, one well exceed the Pennsylvania Department of Environmental Protection's proposed guideline of 14 nanogram per liter for PFOA. In this slide, I try to visualize the total PFOS data in the context of Pennsylvania Department of Environmental Protection's public well water data, and also master well owner network total PFOS data. It seems that uh, one or two uh, PADP public water well water data exceed the 70 nanogram per liter. In this slide, I try to visualize the PFOA plus PFOS data between Pennsylvania Department of Environmental Protection public wells data, and also master well owner network private wells data. We can see that probably 1 or 2 point exceed the 70 nanogram per liter EPA standard. Here is the summary of PADEP and master well owner network PFOS data. Total sample PADEP tested 412 public well water system, and master well owner network tested 68. PFOS detected 103, which is 25% of the total sample, and master well owner network found 40 wells with PFOS, and which is 58% of total sample, and max PFOS detected in master well owner network 16.49, and max PFOS detected on PADEP 187.1, PFOA detected 112 in PADEP result, and which is 27% of total number of wells. And master well on a network found 44 sample, which is 65% of total wells. And max PFOA detected 59.6 in PADEP result, and max PFOA detected on master well on a network 16, above EPA limit of combined concentration of PFOS and PFOA is in PADEP data is 2, and master well on a network 0, and tested PFOS chemical is 18, and master well on network tested 20 PFOS chemical. And one will exceed PADP guideline in proposed guideline of 14 nanogram per liter for PFOA in master well owner network. The Pearson correlation table total PFOS with the distance, depth installed here on-site wastewater treatment. Slide is This slide is basically the comparison of short and long chain PFOS compound among PADP public well water system and master well owner network private well water system. And short chain PFOS compound has little less average value than the long chain PFOS compound in both situations. Until now, the summary of the project, the total PFOS concentration, 18 out of 68 wells had no detectable PFOS concentration in master well owner network data. Most frequently detected PFOS compound where one-third wells had PFOA, PFOS, PFHXA, PFBS, PFHXS, PFHPA. 13 PFOS compound detected in master well owner network sampling out of 20 PFOS compound, with 3 compound having short chain and 10 having long chain. PFOS plus PFOA value in the master well owner network data no well exceed EPA guideline of 70 nanogram per liter of these 2 compound. 1 out of 68 wells had PFOA level that exceed the proposed 14 nanogram per liter PADEP guideline, and no well had PFOS level exceed the 18 nanogram per liter PADEP guideline. In the context of PADEP PFOS data, wells that we sample near to the active biosolid application site were in the lowest range of PFOS sample collected by PADEP, and PADEP basically aiming to collect their sample from industrial naval bases, firefighting training sites. Chain length, the average concentration of short chain compound is 2.35 nanogram per liter, while the average concentration of long chain compound is 5.46 nanogram per liter in master well owner network data. The median value of short chain compound is 0.47 nanogram per liter, and the median value for long chain compound is 2.03 nanogram per liter in master well owner network data. The maximum value of 23.3 nanogram per liter found in master well owner network short chain data, and the maximum value for the long chain compound 57.09 nanogram per liter found in master well owner network data. In the context of PADEP post data, the average concentration of short chain compound is 1.116 nanogram per liter, while the average concentration of long chain compound is 8.94 nanogram per liter. The median value of short chain compound is 0 nanogram per liter, and the median value of long chain compound is 0 nanogram per liter as well in PADEP data. The maximum value of short chain compound is 64 nanogram per liter in PADEP data, and the maximum value for long chain compound is 280.6 nanogram per liter found in PADEP data. Perspective work. We're still on the rudimentary level of this project. We are planning to understand the p-phosphate and transport across topsoil to groundwater. We want to refine and validate mathematical model to predict PFOS leaching and potential risks to surface and groundwater resources based on lab and field result. We are aiming to determine the long-term impact of human and animal health associated risks to the food chain using the Penn State Living Filter PFOS data from another sub-project of this project. The We want to understand PFOS feed transport and crop uptake in a site-specific field study from spray irrigated irrigation with wastewater reclamation facilities effluent. We already started conversation with the USGS and also state of Pennsylvania, and we want to share our data with their data, and we are planning to we use the national PFOS data source as well as our collaborated data sources, geologic, hydrologic, and soil properties data, and make a predictable model for PFOS in the environment. Thank you. I would like to thank our Penn State Extension Associate Brian, Jane, and Susan for their kind contribution in this project. Without their help, it is kind of like impossible to get a master well owner network and communicate with the homeowner. And I would like to also thank my amazing supervisor, Dr. Heather Presendas. Without her suggestion, this project is kind of impossible. And I would like to thank Penn State College of Agricultural Sciences and also EPA for their uh, grant support. Thank you all for hearing me. And I'd like to take any question if you guys have. Thank you.